At Service Logic, we believe the future of the skilled trades lies in training and development. And that's why we created the Edge, a platform dedicated to empowering our greatest assets, our people. From hands-on training to leadership development, Edge is where technicians grow their skills, expand their opportunities, and build lasting careers. Because when people succeed, our companies, our customers, and our industry thrive. This is the Edge. This is the future of the skilled trades.
I chose iConnect training equipment because I already previously had some iConnect training equipment. And I was very pleased with the equipment I had, the quality of it, and pre-designed labs that came with it. So when I expanded it more into the catalog, I decided I wanted to get this refrigeration trainer in my program to expand my program. My experience so far using the TU-155 has been pretty good experience, especially my second year students, and the light bulb kind of syndrome goes off when you see that little flicker in their eye and oh, I got it. That's what us instructors, what we look for is the I got it moment. And this helps me to the I got it moment with my students, and that's what's my goal to achieve.
We are Daikin, the #1 global indoor comfort provider. Our innovative home and building solutions are engineered with energy efficiency and sustainability at their core, ensuring improved indoor air quality for all. From heating and cooling to ventilation, air purification, refrigeration technologies, and connected devices, we're at the forefront of technology, addressing the pressing challenges of sustainability.
All right, everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. All right. So I know there's a lot of noise going on, and that was actually intentional. So we are parked right now, right next to Interstate 65 here in Indianapolis, Indiana, one of the noisiest areas that I could possibly be. And we've got the mobile studio set up. I wanted to give you a tour of the outside before we go inside and actually get set up. So I'm going to switch the cams around. We're going to do a quick run through, and then we'll go take a look at this new studio and everything that it's going to offer you as we go forward. All right. So let's start from out here. So this is going to be the side that's going to represent the HVAC show. So this is an 8.5 by 20-foot mobile studio. We have a drop down on the back so we can actually bring equipment in for doing training and testing and operations. And then we have a whole section to sit outside. We'll have a bunch of things for our sponsors as we move forward. We'll talk about some of those today, and each week we'll actually bring in some new opportunities to introduce you to our sponsors. So I'm going to head inside and we're going to continue with this show. See you all in a second.
All right, everything coming through fine on your side, Jocelyn? All right, so everyone, we're going to introduce you to the new studio, give you an idea of how the show is going to look going forward. So the new studio, we actually have a variety of different cameras. So we're in the podcast section right now. It says the microphone's a little on the soft side. Okay, we can bring that up. So we're going to start with some of our different camera views to show you where we're at. So as we move through the different camera selections, let's go down and grab our, and we're just change views here. Let's go grab this one here on the far right. Yeah, there we go. And in video, so we have a variety of different camera selections. Oh, all right, so we're using the main ones. We were already there. So there's a lot of technology going on in this studio. So, all right, so let's bring this one up top and we'll show everyone where we're at. So welcome to the studio. So in the studio, we're going to have a variety of learning experiences. At the front, we have this whole podcast studio that has got all the production equipment for video as well. And what you're going to see is as we go mobile, we can actually bring training to you anywhere in the country. So how we're doing that, we actually have a complete solar system on this studio. So this trailer is 20 feet long. We have 12 solar panels. We also have our Starlink satellite, which is where we're broadcasting from right now. And then we have 6 kW of inverters and controls, as well as 8 100 amp lithium batteries. So everything that you're seeing, we're actually doing completely off grid, which is one of the things that we like to talk about here is how we better utilize energy. And this is one way we're going to do that. We're going to start seeing equipment coming to the industry that is going to be integrated with solar a whole lot more often. Even this own studio, we're going to be installing a Daikin cold climate heat pump to operate, to maintain the temperature in the entire studio, but then we're going to have equipment on both sides. And to do that, we're going to have a variety of functions for our cameras. These are actually 4K auto tracking cameras that I will be able to operate by myself, or there'll be times where Jocelyn is actually going to be managing things for us, so we can use our cameras from a variety of different places to do training from the entire area. We can change scenes while we're using these cameras so that we can get different perspectives. And we can also focus on different components. Hello, Jocelyn. And that's just one of the cameras. We actually have a couple other. So as we start organizing all of our training content, we're going to be bouncing between the two different sides of our mobile studio. So from here, we're going to focus in the middle, and we'll come back to this one here in a second. We'll show you what we're going to do with these other sides. Let's go ahead and pick one of our side cameras here, maybe camera number 2. And so when we start utilizing these artificial intelligence cameras, we can get different focal aspects from any place within the entire studio. I can do auto tracking with it the same way. I can do hand features that will actually start tracking everywhere that I go, so that it's almost like having your own personal production team, even if it's just one or nobody. And we can change scenes. We have pre-programmed scenes that we can use for when we're doing educational pieces. Like today, we're going to talk a little bit about ECMs and ways that we can introduce ECM technology into the classroom for education on electricity. So there's a lot of ways we will be able to use this studio going forward. One of the things that we're wanting to do is we're wanting to learn from you. What would you like to see? What technologies are you most interested in? Because we're going to have a variety of sponsors for this whole studio project. 2 of those sponsors are going to be equipment trainers. 2 of them are going to be equipment manufacturers. 2 are refrigerant reclamation companies. We're going to have a large school. We're going to have the largest commercial service contractor in the United States. We're going to have the largest organization of contractors in the United States. We're going to have tool manufacturers. We're going to have a lot of things that are going to contribute to your training. And so we want to make sure that we are sculpting it for exactly what you're looking for. On this side, we're actually going to be doing equipment trainers with Daikin equipment. We're going to be working with iConnect trainers, and we're going to have a variety of different technologies. And so what technology do you want the most? Are you wanting to focus on ducted inverters? Are you wanting communicating? Are you wanting air handlers? Let's talk about the things that you need to be able to implement the best products for your training program. And then we're actually going to have a whole nother studio. If we go over on camera 3, we're going to switch sides and we're going to move over to the opposing wall where we're going to have a different selection of OEM equipment. We're going to have another manufacturer of equipment trainers. We're going to have cutaway parts, an entire wall of cutaway components, so that we can actually talk about these products. We can do hands-on education, and then we're going to be introducing our interactive virtual education as well. We're going to be able to take parts off from the wall. We're going to talk about them, and then we're going to actually use software that can break those and dissect them apart even further for educational content in the classroom. We're going to have a tool manufacturer that's actually going to be sponsoring an entire tool and workbench. So similar to the other studio that I've been using this whole time, we're actually going to have another breakdown bench so we can take things apart. We can work on them. I've got additional lighting you put in here. We've got a variety of additional lights that we're still going to be introducing into the studio. And we have a drop-down access door so we can take this out and bring in other pieces of equipment. So let me know, throw it into the show notes or send me an email at cbeck@escogroup.org of what you would like in this classroom, because this is an opportunity for you to help drive this training. And this training is going to be going all over the country. We're going to be going to equipment manufacturers, we're going to be going to equipment distributors, and we'll be able to go on site as well, anywhere we want to. We're actually sitting in front of a Johnstone Supply right now. And so the goal is to do a lot more training and make sure that you're getting the technology and the education that you need to be successful, whether you're an educator or whether you're a contractor or even just a technician who wants to know how to get better with the products out there in the field. So let's go over real quick. Let's take a look at the chat. Let's see if there's anything that we would like to hop into. Oh, good. So George is joining us from Western Kentucky. Osvaldo is joining us. Yeah, it is, Kendrick, it is really cool to have these. And we can actually tap on those and highlight. Jocelyn is just joining us. So we're learning all of this together. There's going to be a lot of things hopping in here, over the next few weeks. A lot of changes for us, a lot of new things that we'll be able to bring to you. And we want this to grow for you. Osvaldo, was the installation recorded? Oh, I did grab quite a bit of the installation of this. So I'll be sharing and dripping out different pieces of content over these next few weeks. So the trailer we had custom made for us. The solar was installed by a solar company here in Northern Indiana. And then I've been doing all of the audio video. So now Jocelyn is joining me to dive into the programming and the controlling and getting this whole experience to flow better for you. So remember, this is just a test. We weren't even sure how well things were going to go, but we had to start somewhere. And so today is actually Jocelyn and I's first day of working together. So there's a lot of team building happening here, and we're going to have good, fun experiences for you going forward. So yes, we will absolutely share that and get that out. George, thanks for joining us. Yeah, the whole point of this was to make sure that you have all of the resources that you need to be successful. And our industry has came together in a very significant way. This was a dream just a couple of months ago, just a sketch of what portable training could look like. And so we came up as a team, came up with an idea of being able to not only have a better studio for me to work from locally, but to be able to take the training on the road, to be able to get to the places that need it the most. And then we introduced the concept to just a handful of industry partners, and they immediately joined forces to make this happen. So it is our industry partners, our manufacturers, our trade organizations that are making this learning experience possible for you. And they are going to be bringing some training products into this lab that are just absolutely mind-blowing. And they're going to be here for you, completely for you. So be thinking about the technologies that you want to learn the most, what manufacturers you want on the show, what things you need in your classroom or as a contractor, as a technician. So what do you think? Everyone kind of enjoying it? Different atmosphere? Yeah, thanks, Tony. Really, I knew you would enjoy this. Tony just finished building his own studio at home. He understands the importance of training and having a place to be able to do that training. And so this training is actually going to be able to go anywhere we need for it to. So let's dive a little deeper into some technology today. We've been spending a lot of time in the industry talking about transitions in technology, transitions in refrigerant, transitions that are just happening as we go through generational changes of labor. And so it's important that we start getting our resources to be able to educate to generations that might learn differently than many of us instructors. Had a very interesting conversation this last week. We actually did a podcast we'll be releasing in a couple of weeks about the generational jump. And I hadn't really thought about it as a generational jump, but we really did. When you think about technicians in the trades, particularly in HVAC refrigeration, but it's in all trades, we have a generational gap. And it really happened in the millennial generation. Typically, when we looked at trades, all trades, we have a lot of tribal knowledge that we pass down from generation to generation. An experienced technician hands it down, as a learning experience with their apprentice, with the person that is traveling with them. And we've learned for decades. We've actually learned for hundreds and even thousands of years that way. Trade organizations were the foundation of most of our modern development. Well, what happens when an entire country educational program steps a little bit away from the trades, and we have that gap of education? Many of us Gen Xers that are in education today, we had shop classes, we had trade classes. I had electrical and electronic classes in high school, and we got away from that for a while. And now we're very fortunate, we're very blessed to have really two generations. So we have Generation Z and we have Generation Alpha that are coming into the workforce wanting to make a difference, wanting to learn, being hands-on. Jocelyn has been here for like 2 hours and learned more about this entire AV system than I have in the 2 weeks that I've been installing it. Okay? That's really what we're here to do. We're here to bring concepts to life. And ESCO is completely committed to helping you bring your training to life. And so one of the things that I wanted to re-look at that I haven't talked about in a little while, and I think it's important, as we move into education and bringing things to life, I want us to start sharing ways that we all bring education to people. When we do things, when we create things that people enjoy, I want you to share them with us. I want to be able to come to you and bring some of your training animations to life so that we can share them with an entire industry. One of them that is very interesting to me and very important is understanding electricity. Remember, this entire studio is running off from solar energy. We're bringing in solar energy, we're converting it into DC voltage. We're charging our batteries with DC, and then we're using inverters to step that up to AC voltage. This entire studio, it has a 50 amp, 240 volt service. So we're going to be able to power any equipment that we want in here at any time with no electricity. And it's the technologies that we are responsible to educate the next generation of technicians on. And many of these technologies we ourselves didn't actually grow up with. So we are learning and we are giving back at the same time. So when we look at electricity and the way we generate and distribute electricity, there's been a product that's come to our market that is really fun to explain and can be turned into some really cool educational experiences. The ECM, the electronically commutated motor, is now being used in most products. The ones that I have actually been donated to us from Johnstone Supply. All warranty products that have came back, many a times weren't actually bad, and so they are dedicated to getting products in the hands of the industry. So as an educator, if you're not currently working with your local distributor, I highly encourage you to. They have a lot of products that end up going to the scrap that really should be going into the classroom. Prime example is an ECM. Well, what is an ECM? When we look at an ECM, we have a lot of analogies we can use. We can talk about inverters, we can talk about modulation, all using the same principles. An ECM is using a very similar architecture as what an inverter compressor is doing. They're actually the same technology because it's the motor that's driving the compressor. Well, what are we doing? Well, we're very simply taking an incoming AC voltage, single phase typically, and then when we think about that solar that was happening on this trailer, we're changing our modulation, right? We're bringing in a DC, we're inverting it to AC. Sometimes we're actually reconverting it back into DC for power supplies, because DC voltage is very easy to modulate. It's easy to control. So with an ECM as well as an inverter compressor, what we're really doing is we're taking a motor and we're going to use a 3-phase wiring for the actual motor itself, which is really nice. We get rid of the capacitor, which is one of the common failure components. You know, that weak winding within a motor we can actually eliminate. We go to a 3-phase winding. Very rarely have problems. But to control that, we're going to have our single-phase AC coming in, and then we're actually going to convert our single-phase AC into a DC voltage, right? It's the entire process within the ECM module, as is in an inverter control board for a compressor. We're going to bring that single-phase AC in. We're going to rectify that into a DC voltage. We're going to store it in capacitors. And the great thing about that AC voltage, remember, when we are measuring AC voltage with a meter, we're measuring RMS, root mean square. So we're not actually measuring the peak voltages within that AC sine wave at the top or the bottom. We're getting an average. So when we convert over to DC, we are actually gaining those peak voltages. So we're actually on a 240 volt system. We're storing about 300 volts DC. It's about 130% of its incoming voltage. If this was a 120 volt control module or 120 volt inverter, like on a 120 volt ductless system or a inverter refrigerator, same principle. It's 130%. So if it was 120 volts AC coming in, we're going to have about 150 DC volts stored in the capacitor. So that 240 coming in, it's going to store about 300 volts in DC. And the cool thing about that is we can now take that nice solid DC supply and we can fire it off. And we typically look at the design of that as an insulated gate bipolar transistor. It's a set, actually. We have 6, think of them as switches. So we have the DC coming in. We can separate it out into 3 lines, and then we can control how fast we fire off that, in this case, 300 volts into the windings of our motor, whether it is a ECM or whether it is an inverter. And so what we do is we take those 3 lines, 2 switches on each, right? And we can sequence them to be able to control that 3-phase motor in any direction. I can go forward, I can go reverse, and I can change the speed of it simply by changing the frequency at which I manipulate my switches. The way that I'm controlling the speed of my motor is by frequency. My voltage stays high and I can modulate that frequency. That's kind of it in a nutshell. When we look at the motor itself, whether it is an ECM, just the motor, or whether it is an inverter compressor, we're going to have 3 wires. It's just a 3-phase motor, right? Easy to check resistance between them. They should be the same on all legs, A to B, B to C, and then A to C. And then our module, we can many times actually test the resistance coming through the board. And so there is diagnostics that can be done to the module on an ECM or an inverter. Now, what is the difference between an ECM constant torque and a variable speed? It's simply the performance of our programming in our control. So our ECM constant torque control is just taking AC fan speeds. So it's got pre-programmed profiles. How fast does it ramp up? Where does it stay? How fast do I ramp back down? We pre-program some profiles, and that is our fan speeds. When we get into the true variable speed, then we're actually going to start using a modulating DC signal to be able to control the speed that we want to fire off those switches. So really the only difference between the ECM constant torque and the ECM true variable speed is that our module has different control of the way that it's sending the voltage, the signal to the motor. The motor's the same. So I could have one module that is designed for the 24 volt AC incoming signal to feed some pre-programmed ramp profiles, or I can use a variable signal to tell it where I want it to be. It's all just in the module. So when we use that concept in the classroom and we help our students understand and help our technicians understand that an ECM, the motor itself is very difficult to burn up. The module could. Many times it's in communication between. But when we start talking about electricity and helping understand what electricity is, the visuals are really nice to have, right? Well, we can use an ECM for a really, really simple and really cool demonstration of electricity. So think about this. If we have a 3-phase motor, and my goal is to induce a voltage into my windings so that I can create a mechanical rotation. I can convert my electrical energy into a mechanical energy. Okay, that's the principle of a motor. Well, what happens if the energy is in reverse? What happens if I start with mechanical energy, but I've got magnetic fields? I actually begin converting my mechanical energy into electrical energy. It's the entire principle of a generator. All a generator is a device that turns a rotor inside of a stator to produce a voltage. And so many ECMs get pitched. If they have a bad module, rarely do mods get replaced, even though I personally believe in replacing mods over complete motor assemblies. But many of them do get pitched from our local distributors and even contractors. And so in the classroom, you actually have a perfect item to use to help understand that entire process of taking electrical energy to create mechanical energy and mechanical energy to create electrical energy. Now, we're going to move over to one of my favorite toys. Created this particular one I did back in 2018, but I've done a few of them. And we have to be cautious of voltages and understand that it is an electrical process. But anytime we can take a concept and we can show it in a fun way, the educational opportunity increases. So let's think about this. If I take my ECM and I remove my mod, I now have either a motor or a generator. And it can generate in 3-phase AC. So if we can utilize a device to create a mechanical force, we can get an electrical force. And we can show how generators, how a lot of our power plants are operated. If we have a generator supplying electricity, why can't we show that entire principle in the classroom safely? Okay, so here's my favorite demonstration. Our ECM minus the mod now becomes a 3-phase generator. And if we take that 3-phase generator and let's move over to camera 1 maybe. Yeah. If we take that 3-phase generator and we attach it to a mechanical device so we can get enough RPMs off from it, we can demonstrate how we make electricity. And this was a very simple project. Goodwill for the exercise bike or Facebook Marketplace, inexpensive places to get your older bicycles. I like the older bicycles because they have weighted wheels, which maintain some of the momentum once you get it up and going. A lot of them, like this particular one, actually had a rubber tread on the tire. This thing has been used so much, the rubber tread was burnt off by my students. And I've actually right now needing to replace the rubber that I use on the actual shaft. And so what we're going to do is we're going to attach a EC motor, not the mod, but just the motor. And we can now show electrical distribution. We're bringing in our 3 phases. And in that, we're going to use single phase loads. In this case, I'm just using standard electrical sockets. And now what we'll have is we'll have a lead from A to C, A to B, and then B to C. so that our three-phase is actually generating 3 complete loads, network of load. And we can now show how we actually generate electricity. And I'm hoping it's going to work fine. We were playing with it a while ago, and I had so much of the rubber burnt off from my motor shaft that it wasn't going the greatest. But you can actually generate a significant amount of electricity. When I'm getting full contact off from this, I can actually produce 230 volt 3-phase AC. Now, it is non-grounded, which is the thing we need to be cautious of, and I do encourage running a ground from it to dedicated ground. I used to run a anchor down into the concrete and attach it onto an iron post just to make sure it was a completely grounded circuit for safety. But it shows electrical load, and the cool thing about it is, if you think about that load, what happens if I reduce my electrical load? It actually reduces the resistance mechanically. So we can actually show how electrical resistance correlates to mechanical resistance. And so one of the fun things to do in the classroom is to have a variety of wattage of bulbs, different electrical resistance, because that's what it is, remember, it's resistance, so that I can demonstrate a variety of mechanical resistance based on from an electrical load. So that's a pretty good workout. We've been working hard over the last couple of weeks. All right, so one of the ways that I do this is to keep it inexpensive in the classroom. I actually use heater hose, right? So you need to have something to create friction. So I use heater hose from a local auto parts store. And this one was 1/2 inch. So that 1/2 inch will slide over a standard 1/2 inch shaft, makes a nice connection. On that one, I actually take a 1 inch, put it over to make it larger. How you mount it really depends on the exercise bike. But it's a fun way to demonstrate how an ECM works and how we produce electricity, all in a simple item. Any questions? I'm enjoying this. Having the ability to walk around. Yeah, it is a fun one, Tony. Yeah, Osvaldo. So Osvaldo had some questions on solar. We're on what? So with the solar, I have a feeling that's something that we're going to be learning more as we go forward here, because it's become an important part of what we do. We actually have two companies out there. One of them is EG3, and the other one is Hotspot Energy, EG4, I think it was. Anyhow, we have two different solar companies that are now putting out solar-powered heat pumps, ductless units that run completely on solar. Because if you think about that, let's go back again, okay? Come on, let's go talk about this. Okay, if we are, where are we at? On that one? All right, think about this, even from the solar aspect. If the whole purpose of my mod or my inverter control board is to take AC voltage and convert it to DC, what if I started with DC? That's what we're doing with solar panels. We're starting with DC. And with a solar panel, we're actually able to put them in series. And then we can actually put them in parallel onto those series circuits. So we can have a combination of series and parallel circuits to be able to get the voltage and the amperage that we need. And we can produce high DC voltages off from solar panels, enough that we could actually operate our system and not need to convert from AC to DC. That's where a lot of our loss is in an inverter control board, or an EC, is converting our AC into DC. So solar is a very interesting thing to be able to incorporate into the classroom as we're making these discussions, because it is the future of our industry. We are going to see a lot more solar. Remember, this whole thing's going to be powered off from solar. We're just going to be wasting some of our energy when we convert from AC into DC. So that direct DC to DC correlation in solar is a really, really, really nice thing to understand and at least implement into your classroom a little bit. Any other questions?
Yeah, that comment from Howard.
Cool. Yeah, Howard, you're right. Technology is moving so fast right now that we have to keep up with the technology that is around us. And that was the whole purpose of developing this mobile studio. This is a big undertaking. It took a lot of support. And we have an entire industry that stepped up to make sure that they can help contribute to the efforts to bring you everything that you need. How we doing? Boy, we blew through that one already.
Roughly 30% in loss from DC.
That's a great one, Todd. Yeah, so when we look at that loss, that is a pretty significant loss going from DC back into AC. All right. Well, that is about it for today. I know it's a little short. Any questions along the way? Let's bring that one up. I know you don't like seeing yourself yet, but we'll get you over that yet. And everyone, I want you to be looking for Jocelyn as we're out and about. You know, when we're at a conference, walk up and say, I've got some interesting things about our industry that I think that you would like. And Jocelyn didn't come from our industry, but she has been welcomed into it. And so now it's all up to us to bring her some of the fun and the enjoyable things of our industry. So we're grateful that you all joined us. This was a bit of an experiment. We wanted to put a little education in it as well. And every week going forward, it's going to continue growing and getting better and adding new products and new technologies to this thing. So we thank you all for joining us, and we really look forward to seeing you again next week on Did You Know? The ESCO HVAC Show. Bye, everybody.